So addition goes back together as what with our properties? Multiplication. So I could write this as x times x plus 2 equals log 2 of x plus 6. So if you see logs added or subtracted, or you see a number in front that you could put up as an exponent in an equation, you should always do that. So those properties, putting them back together. Because now I can say that since these are both log 2, I can set this equal to this. But you can't do it if it's addition subtraction. So I can say I'm going to distribute x squared plus 2x equals x plus 6. Oh, it's a quadratic. So I could subtract the x over, and I could get x squared plus x minus 6 equals 0. Also super great on the video. I just feel like you should have to know how awful it was. Like I was trying to record it in my hotel room on my Surface, and my Surface just like had a mind of its own. And like I would go to write, and it would scribble over here. And then at one point I went to erase, and it just scribbled. Do you remember that part? And I was like yelling. I was so upset during the video that it wasn't working, and I kept pausing and trying to fix it. And then I would come back and like, I think it's fixed. Then it wasn't fixed again. And it was really sad. It was just a lot of me sighing on the video. And then I went to typing, and then I just apparently can't type math and think at the same time, because then I just typed the wrong things. And I factored this wrong, because I put 6 and 1, which obviously it's not 6 and 1, because I need to subtract to get 1. So it should be 3 and 2. It was just sad. Like, I should be fired if someone watched that video. Like, they'd be like, you are not, you could not teach math. But it would be positive 3 and negative 2. So you get x equals negative 3 and x equals 2. I will forewarn you that not everything with logarithms is factorable, and there will be times that you have to do the quadratic formula to do these problems, and that's kind of gross, but there will be times we have to do that.
Well, on the one on the computer, when you had the equals 6 and like it was negative 6,
oh,
so would that still be extreme?
It's still an issue. So like we have negative 3 and positive 2 here. Just like rational expressions can have extraneous roots and square root equations can have extraneous roots, if your domain is not all real numbers, you have to make sure you look at your answers and make sure that they actually work in the problem. And so this is an issue, right? We cannot plug negative 3 in here because we cannot take the log of a negative number. So you have to throw that out. The great thing is I gave you odd problems in the book because I want you checking your answers to make sure you're getting the right answers. So if you forget that today, when you check in the back of the book and you see there's only one answer, it'll probably remind you. So 2 is the only answer. And yes, there could be a time that both answers are extraneous and there's no solution, which is kind of frustrating because you did all that work to say no solution. But okay, so that's kind of the one idea. And then there comes this problem. Which why there's one of my math teachers from high school was at this conference and I was working this problem out, and he said, why in the world would you ever make your students do a problem like this? And I said, well, because it's in the book. But why would you do that? And so he was just really, he told me to tell you that you shouldn't have to do this problem. But a former teacher of mine that was at this math conference said that this was the worst problem ever and I shouldn't make you do such problems, but I'm making you anyway. So, the first thing I'm going to do on this is I'm going to multiply by 2 because that's going to make it look a little better, right? Not much, but a little. I think it's a good problem because it makes you have to think a lot. There's a lot of steps. That's not such a good problem. There's a lot of room for error, as I showed on the video, because I messed up multiple times. But it's also good to make it fit a certain pattern. And it's always a good thing to remind us of a way that I thought you did in Algebra 2, but we'll see what you guys say, if you remember doing this or not. When I first did this problem, I wanted to like ln both sides, because if I knew if I ln, I could pull the x out. But can we do that with subtraction or addition? We cannot. And there's no way to get rid of it so that we can do it by lning it. So what we have to do is we have to make this fit a pattern for us. So just humor me for a minute and trust me that this works, okay? So what I'm going to do is I'm going to multiply this whole equation by 2 to the x. How do I know to multiply by 2 to the x? Well, because I followed the example in the book. How will you know to do that because whatever this base is what you'll multiply by. So if this was 4 to the x and 4 to the negative x, you'd multiply by 4 to the x. If it was e to the x, you'd multiply by e to the x. So whatever's in the problem, that's what you're going to multiply by. And as we go on more, I think I'll be able to show you why.
So is it always the first one?
Yes, the positive one. And then we have to remember our exponent rules. What do I do with exponents when I multiply? I add them, so I keep the basis 2, and then x plus x becomes 2 to the 2x. Oh, that's weird, right? And then on this one, 2 to the x times 2 to the negative x, if I add those, does that just become 2 to the 0?
Wait, so 2 times 2, why don't we make it?
Well, because when we multiply with exponents, we don't change the bases, right? Like if you have x to the third times x squared, that's just x to the fifth. And it's the same thing. If it's 2 to the third times 2 squared, that's just 5 2's. We don't say 4 to the fifth, right? People want to do that, but we don't. Okay. And then over here, I can't take 6 times 2 to the x. Like that's not 12 to the x. That's just 6 times 2 to the x, or 2 to the x times 6. So I'm going to rearrange this to hopefully jog your memory on something, maybe not. But I'm going to move this over in the middle. So I'm going to rewrite this as 2 to the 2x. I'm going to move this in the middle, so that's going to become minus 6 times 2 to the x. And then 2 to the 0 is just 1, minus 1. And I'm going to say that's equal to 0. Sort of kind of with me on where I got that. So the reason I did this is this now fits quadratic form, or it now fits where we could do u substitution. So this has nothing to do with the problem, but I'm just trying to jog your memory here. Maybe in Algebra 2, you remember doing something like x to the 6th plus x to the 3rd minus 2 equals 0. And you could factor it, and you could set up a u substitution, and like you talked about that if the middle term was half of the leading term, then that's set up for quadratic form. And you could do something like u equals x to the 3rd. And if u is x to the 3rd, then this becomes, I'll write it in 2 steps, like x to the 3rd squared, or that becomes u squared plus u minus 2. And then you could just factor it like normal and then plug back in what u was. Any vague memories of that? And on my video, I said, you should remember this from Algebra 2, but who knows what you did in Algebra 2? That's what I said on the video. But that's what it works out, that you can solve things that are not quadratic if they fit that form. And the rule is that this has to be half of this exponent. So go back over here. Is this exponent half of this exponent? So we can make our u equal to 2 to the x. So if I do that, think about this as like 2 to the x squared. So this becomes u squared minus 6u minus 1. And I'll tell you that every type of problem like this, it works out. There are some that they'll set it up exactly like this. They won't make you do all that other work before there. That they'll just work it out for you that you could just start setting it up. If I was a nice person, this would have been factorable, right? But it's not. So we have to do complete the square of the quadratic formula. On the video, I did the quadratic formula incorrectly. But I did the quadratic formula because I knew that you guys liked it better than completing the square. So I'm going to do the quadratic formula. But remember that normally the quadratic formula is x equals. This is u equals, right? So we could say u equals negative b plus or minus the square root of b squared minus 4 times 1 times negative 1, which I'd left out the negative in my video. At one point in the video, the computer was so awful, I wrote a question for you to answer that says, why does my computer hate me? I was kind of looking forward to your responses. Now you don't have to watch it. So I think we get 40 here, which I'm going to simplify to 2 radical 10. And again, this is stuff we've been doing since chapter P of being able to do the quadratic formula and simplify it. Very important thing. I could divide by 2, and I think I get 3 plus or minus radical 10. But remember, that is what u equals. We want to know what x equals. I'm telling you, it's like the never-ending problem. So u equals 3 plus the square root of 10. And what was u? So we can say 2 to the x equals 3 plus the square root of 10. Notice I didn't do plus or minus here. What is 3 minus the square root of 10? Is that a positive number or a negative number? A negative. Is an exponential function ever going to equal a negative number? So I just threw out that negative answer, and I'm just going to do this one. So I'm going to ln both sides. Finally, I can ln both sides. And I can pull this x out front, right? That's why we ln both sides. And I divide that over. So I have divided by ln of 2. And then you'd have to use a calculator. And the funny part is I really messed up this problem online, and the answer's not really that much different than what I got. So I don't know if I should be happy or sad about that, but you definitely want to practice typing this stuff in on your calculators because you want to make sure you're putting parentheses in correctly. But I think I got this to equal approximately 2.623. And just like I said on the video for day 1, you need to get in the habit of giving me both answers, the exact answer and then the answer on your calculator. So you shouldn't be using your calculator for the hand. And there's a question just like this on homework, just different numbers, but same process. And so I wanted to give you that example to do. I'm not doing the rest of this. I'm gonna do this. I'm gonna make this video and hopefully have it posted by the end of the day. But if not, you can do it. You can watch it tomorrow. So day 1 homework. And then for today, if you've done day 1 homework, you should be able to do these 5 problems. Notice 29 is out of order here. And then tomorrow, I'm going to have you do those 4 problems. But if you want to just write them all down and do the ones you can for now. But so I'm calling this day 2. I'm calling this day 2.5 because I haven't finished the notes yet. And I'll make that video on my prep and post it by the end of the day. So if you have a chance to watch it tonight, you can. And if not, you can watch it in class tomorrow. Okay?